With this unit about logic, we have to start with a bunch of vocabulary because, of course, with any start of a unit, we have a lot of vocabulary. Today, we're going to work on what are called conditional statements. So we're going to not be doing any like adding, subtracting, multiplying, dividing kind of math today. We're going to be doing logic, where we're going to have to write stuff down like in sentences. It's still technically math because we're using logical thinking, which is a branch of mathematics. First thing we're going to define today is called a conditional statement. A conditional statement is a statement with two parts. The first part is called the hypothesis. It's going to feel sciencey for a second. Hypothesis. And the second part is called a conclusion. One way you can think about conditional statements with a hypothesis and a conclusion is kind of like a cause and effect situation. So if the hypothesis causes the conclusion, you have what's called a true conditional statement. When we are talking about hypothesis and conclusions, we're going to use the letters P and Q. I know that's confusing because lowercase p and lowercase q kind of look the same the way they're written, but we're going to use good handwriting. We're not going to get confused. When we do conditional statements, we're going to say P causes Q. The hypothesis is P and the conclusion is Q. Let's highlight that. Hypothesis is P, conclusion is Q. A truth value just tells you the validity of the conditional statement. Basically, is the statement true or false? Now, one of the things I need you to do today is not make it weird. Don't give me a bunch of if, ands, or buts. Just tell me if it's true. Does one thing cause the other? So first things first, let's make sure we understand what is what. Let's underline the hypothesis and circle the conclusion in the following conditional statements. Number one, if you liked it, then you should have put a ring on it. This is a conditional statement because it starts with the word if. Then we have a hypothesis, if you liked it. It ends, or the second part starts with then, and then it says you should have put a ring on it, which is the conclusion. So we have our hypothesis, the cause, and we have our conclusion, the effect. But in between the cause and effect, in between the conclusion and the hypothesis, we should see the words if and then. So if we see a second example, 1b says, if there exists 2 points, then there exists a line. What is the hypothesis here? Say again? The if, very good, the if statement. If there exists 2 points, what's the conclusion? There exists a line. So after the then is the conclusion. If hypothesis, then conclusion. If hypothesis, then conclusion. Now again, we can write our own conditional statements, especially if they give us the P and the Q. In 2a, it says P is you are a guitar player, and Q is you are a musician. I just said magician, musician. If we put that together as a conditional statement, we started off with the word if. If, and then our hypothesis. You are a guitar player. What's our conclusion? Then you are a musician. I keep wanting to say magician. All right, let's talk about the validity of that statement. So if you are a guitar player, then you are a musician. Is that true or false? If you play guitar, are you a musician? Do we know what a musician is? A musician is somebody who plays music. So if you play guitar, are you somebody who plays music? Yeah, this is a true conditional statement. So we're going to put a big OT right here for true. B. If P is angle A measures 90 degrees, and that should say Q. Does yours say what mine says? Okay, cool. Let's fix this right here. This P actually should be a Q, so mark that out for a second. Make that into a Q. But our if statement should say if what? Okay, I think that murmuring was if angle A measures 90 degrees, that's our hypothesis, then what's the conclusion? Very good. Angle A is a right angle. So we can write an if-then statement for basically anything, but after we're done, we have to take a second and check the validity of the if-then statement. So let's think about the geometry we know so far. If angle A measures 90 degrees, does that mean it's a right angle? Yes, so this is a true conditional statement. Conditional statements are where we start logic. But we can also do a whole bunch of things to these logical statements, to the P's and Q's. The first thing we're going to do is called a negation. Do you see this like funky little symbol right here that says like squiggle? Okay, a negation is basically like saying not. So when we put the squiggle in front of P or the squiggle in front of Q, we're saying not these things. A negation is a conditional statement with the opposite truth value. A negated conditional statement is written by including variations of the words like not, isn't, doesn't, wouldn't, shouldn't. Any of the no words or contractions are going to be included in a negation. So if I want you to negate the ball is red, what would you say? Yeah, the ball is not red. That's a negation. We're just saying not. Negation is a not. So for B, the angle is a right angle. How would you negate that statement? That's the actual question. How would we negate this? The angle is not a right angle. So a negation, again, is basically just adding the word not to one of your parts of your conditional statement. But again, here's what I want you to really clock right now. That little funky symbol in front of it, the little squiggle, that's going to tell us that we want to say not. So not P or not Q. We add the word not to our sentence for that statement. The second thing we can do to these conditional statements is called the converse statement. Not like the shoes, but we're talking about a converse conditional statement. What is the difference? I have to kind of scroll around a little bit. Keep your eyes on where it says converse. I'm going to show you a regular conditional statement. What's different between the regular conditional statement and the converse statement? Yeah, the P and the Q, didn't they switch sides? That's exactly what you're doing with a converse statement. So instead of writing a typical P then Q, we're going to write the converse. We're just going to basically switch the hypothesis and conclusion. That's it for a converse. Meaning, if we want to write the if-then statement for 4A, that's the converse, so we switch them. This time we say if what? You are a musician. That's my current hypothesis. Then what is my conclusion? You are a guitar player. All right, let's talk about the validity of that statement. The truth table, truth value. So if you are a musician, then you are a guitar player. Is that true or is that false? Why is it false? What else could you play? Piano. What else could you play? Cello, tambourine, What's that thing where you smash them together like this? What am I thinking of? Cymbals. You can play drums. Those are going to be called preview. Those are called counter examples. You've just showed me an example that proves this to be false. This is a false conditional statement because the converse, when we switched it around, doesn't mean it's true anymore. Let's do the converse for the second example. So again, what's our if-then statement now if we're writing the converse of these P's and Q's? If angle A is a right angle, then what? Angle A measures 90 degrees. We are literally just switching around the if-then statement. That's the converse. We're flip-flopping it. But every time we write a conditional statement, we're going to talk about the validity, the truth table. So if angle A is a right angle, does that mean that it is 90 degrees? Yeah, this one is still true, which is very interesting. That both the regular version and the converse, we should put on my desk, are true. Do we understand converse conditional statements? We just flip-flop the P's and the Q's. Okay, let's go to the back of these notes. We've got a few more things we can do to these conditional statements. One of them is called the inverse. Again, comparing this inverse to a regular conditional statement, what have I added to the P's and the Q's? Little squiggle. What did the little squiggle mean? Not. So what word are we gonna be adding to our conditional statements here? But we're gonna have to do it to both of them because you see how the squiggle is on both P and Q? So what happens here is an inverse statement is a statement where the hypothesis and conclusion are both negated. They're both in negations. We're going to put the word not in both sentences. But remember, we've gone back to where P's and Q's are in the correct order. Converse was switching them. Inverse is telling you not. So if we write an inverse statement for our P's and our Q's, we start with the word if. If. For this one, we don't switch P and Q. So we're going to say if you are not a guitar player. See how I added the word not in there? So what would you write for Q? If we said, if you are not a guitar player, then what? Then you are not a musician. I still said magician. Oh my goodness. Why am I struggling? I'll give you a second. That's a lot of words to write, so I'll give you a second to catch up. But again, we put P and Q in the correct order because that's what it told me to do. And we added the word not because of the little squiggle. I'm going to let you try 5B on your own. I want you to write the inverse for that P and Q. Let's see how we did. Like Mr. Williams said, you could use a word other than not as long as it was one of the not words. Doesn't, shouldn't, wouldn't, couldn't. But here's how I would personally write this one. I would say if angle A does not, let me write that in red, does not measure 90 degrees, then angle A is not a right angle. As long as you have a not word in there and it makes sense, you have written the inverse. Inverse is the nots. Right? Look at us writing sentences in math class. Please tell your English teachers, they're going to be proud of me. But what we didn't do on number 1 or 5A and 5B is talk about the truth value. Because the truth value is going to change for each of these conditional statements depending on what the if-then statement is. So for A, it says, if you are not a guitar player, then you are not a musician. Is that true or false? False. Tell me why. Okay, for the next one, if an angle does not measure 90 degrees, then it is not a right angle. True or false? True. Yeah, we know that it has to be 90 degrees to be considered a right angle. So far we have done regular conditional statements, P to Q, if P then Q. We've done the negations where you just say not. We've done inverses and converses. Converse was the flip, inverse was the nots. Now we get to do everything all at once. The next one is called a contrapositive. Say the word contrapositive. Whoa, that's a lot of things happening. Look at what letters I've given you there. What do you see is next to both letters? The little squiggle, right? What does the little squiggle mean that we should put in our sentences? Not. Very good. What else do you notice about P's and Q's? They're switched. So now we get to do everything. The longest word, contrapositive, we do the most things. We switch it and we make them nots. So a contrapositive is a statement where the hypothesis and conclusion are switched, which we noticed, and they are both negated. So now we're doing everything. Contrapositive. Con means switch. Contrapositive, make it the not. Okay, let's do that one. We would first say if contrapositive. So the Q goes first. It's actually the first thing. It's the if statement. If you are not a musician, I spelled musician wrong. Then what? Then you are not a guitar player. Very good. Oh, I wrote off the screen there a little bit. Okay, let's talk validity of that statement. If you are not a musician, then you are not a guitar player. True or false? So, you're definitely not a musician. Is there any way you could play guitar? No, so this is actually a true statement. If you are not a musician at all, no music, means you don't play guitar. That's true. Because otherwise you'd be a musician. (6b) says if an angle measures 90, or wait, I was just reading the whole thing. If P is equal to angle measures 90 degrees and P is angle A is a right angle, the contrapositive is if angle A is what? Ooh. Ooh. There it is, not. Remember, we're doing contrapositive. It has little squiggles, so we know it needs to be the opposite. It needs to be the not. Is not a right angle. Then what's the conclusion? Then angle A does not measure 90 degrees. Fabulous. Okay, let's talk about the truth value of that one. If A is not a right angle, it does not have a measure of 90. True or false? That's true. Right angles have to be 90 degrees. So if it's not a right angle, it's not 90 degrees. Mm-hmm. Just a couple more vocabulary words here for us to work with. Equivalent statements, which in Algebra 1, you would have seen the word equivalent, and what did you always probably write down next to it? Equal or same, okay? Same thing happens here in logic. These are going to be equal or the same sort of statements. Equivalent statements are both true or both false. So conditional, your P, if P then Q, and your big switch, contrapositive, will always have the same truth value. So they are equivalent statements. Your converse and your inverse will always have the same truth table. It will always have the same truth value. So those are equivalent statements. So your normal and your super switched around are equivalent statements, and your single switch or simply negated are also equivalent statements to each other. Which leads us to our last vocabulary word for the day, which is biconditional. Excuse me. We've seen that prefix bi before in bisex or bicycle. What does it mean? Two. So biconditional means it can go both ways. A biconditional statement is a special case where a conditional statement and its converse are both true. Or basically, like literally, it's all true. This kind of statement follows the phrasing P if and only if Q. So we've got new words to introduce to you right here, if and only if. So when you see these in a statement, meaning there's not an if at the beginning or a then in the middle, it's just in the middle you see if and only if, that's called a biconditional statement. Notice also that the arrow switched to going both directions, meaning I can read this P then Q or Q then P. It goes either direction because the arrow goes either direction. So if we're going to write our statements that we've been working with as biconditionals, here's how it would work. You would say, no if. You are a guitar player if and only if you are a musician. Do you see how there is not an if-then statement for biconditional? We just stick if and only if in the middle of the P and the Q. But we still have to decide if that's true or false. If you are a guitar player if and only if you are a musician. Is that true? Why not? It is false. Tell me why. Say again? I just can't hear you. Yeah, you don't have to be a guitar player to be a musician. We already said this earlier. What other instruments could you play? The drums, the piano, the cymbals, the triangle, the tambourine. So that's a false biconditional statement. For 7b, if we're making that a biconditional statement, that means we start with P, angle A measures 90 degrees, and what do we put in the middle? Very good. If and only if. And then our conclusion, angle A is a right angle. Okay, let's talk about the validity of that biconditional statement. Angle A measures 90 if and only if angle A is a right angle. True or false? If it's 90 degrees, do we know for sure that it's a right angle? And if it's a right angle, do we know for sure it's 90 degrees? Yeah, that is a true biconditional statement. No matter what the hypothesis was, the conclusion is true, both directions. Now here's something before we lose this. Here's something that makes biconditional statements a lot easier. We had to think kind of hard about true and false for these two. What would be really easy to do is look back at the work we've already done. So just follow along with me. You don't have to write this down, but I want you to think. For that guitar statement, we started off with P then Q being true. When we did Q then P for the guitar statement, you might have to flip your paper over. Did we say that was true or false? So that was the converse. Did we say that was true or false? Example 4, part A. Did we say true or false?
True.
So if we say false, are those two statements having the same truth value? So there's no way its biconditional statement can be true because those were not true. So we would say P if and only if Q is also false. But when we did the angle A example, and we said P then Q is true, what did we say for Q then P? So example 4, part B, did we say true or false? We said true. Notice how both of these are true, And guess what the biconditional statement was? It was also true. If you notice that you're getting trues for everything or falses for everything, your biconditional statement is going to be true. If you've got mixed and matched true and falses for when you switch things up, your biconditional statement has to be false. They have to all be the same thing. All true or all false. Kind of like the two examples we saw here. Okay, again, now that I can show it to you on my screen because I finally pulled it up, this is what you're working on for the rest of the class, and if you don't finish, it becomes homework. So we are going to cut and paste all of the vocabulary sentences onto here. But what I do want to do before I let you get too far is I want us to decide the validity of the given statement together as a class so that we know whether the converse, inverse, contrapositive, and biconditional should be true or false. Again, some of these are opinions, but not actually really. So number 1, if you do your homework, then your grade improves. Is that true or false? True. Okay, great. Everybody circle true. Thank you for realizing that, and I need you to take a second and reflect on that, because some of us need to take this to heart, that if you do your homework, then your grade improves. I think we know this. Okay, number 2, it says, if you brush your teeth, then you do not have cavities. True or false? Yeah, can you brush your teeth but still like get a cavity if you don't brush them right? Or floss? We should probably start flossing, everybody. So we're going to say that this one is false. It's not necessarily true that if you brush your teeth, you straight up never have cavities. You have to brush your teeth well and floss. If you hold a puppy, then you will smile. True or false? Oh, what? Y'all, that's true. Y'all ever held a puppy? Yeah. You gotta smile when you're holding a puppy. That one's kind of an opinion, but your opinion is wrong if you say false. That is true. If you've ever held a puppy, make you smile. If you break your arm, then you will go to the hospital. True or false? True. And if that's false, then you must live in the mountains somewhere and just way stronger than me. But we're going to say true for that one. And last but not least, if you go outside in a Texas summer, then you will sweat. True or false? Heard. Okay, so we've decided the given, whether it's true or false. I want you to figure out the rest of them. So you'll cut and you'll paste and you'll tell me whether that statement is true or false.